Well, good afternoon. Lunch hour, just when you want to be holding a panel, when people are getting hungry. But welcome, everyone. It's a great week for those who are from British Columbia to have a panel like this. We know that here in Vancouver, just this week, as part of Web Summit, we had our federal government, provincial government, and the telecom TELUS announce 2 new data centers for the city and an expansion of a third in another part of the province. So we're here to talk about this $400 billion AI infrastructure opportunity with 3 guests who understand all of this stuff inside and out, top to bottom, the entire system here. So maybe, Rodrigo, I could start with you, and you could tell us a little bit about what SambaNova contributes to this world, but also if you could maybe answer the question, start off with what we hear a lot about, which is power. And scaling AI is increasingly limited by access to power. So, I mean, by one estimate, global data center power demand is projected to grow 165% by 2030. So how do we tackle the energy bottleneck that we're seeing with traditional?
Yeah, I think that's a really, really important aspect of the scale out of AI. And so SambaNova, we are a startup that was started back in 2017, building AI chips, really focused on inference. And today, as we get into the agentic flow, what we're seeing is more and more need for computing, more and more need for power, more and more need for these very, very smart, large models. And so what we're focusing on here as part of SambaNova is creating chips, creating infrastructure in systems that allow us to actually go into these data centers that are incredibly, incredibly power constrained. And so if you look at an NVIDIA rack today, you know, it's as much as 100 kilowatts. We're trying to get more performance in that rack at 10 kilowatts. And so this is really where you want to drive that power solution at the core of the tech down to the chips so that you can get more performance for the power that you have available to you while these applications continue to scale.
Okay, and how is that working? Like, what sort of orders of magnitude are you seeing?
Well, so today, I mean, actually Stanford did a really great paper late last year that said per watt, we're getting 4x more tokens out for every kilowatt that you actually pump into these systems, and you're coming out of SambaNova. So what it shows you is if you actually take a technology that wasn't really originally designed for training, because you have a lot of chips that are originally done for training, moving into inference, or chips that are doing both training and inference, you're incurring the cost of these training chips for what's ultimately a very high volume, really high efficiency type of use case. And so SambaNova, we went back to first principles, back at Stanford, and really started thinking about what does it look like if you need to inference at scale? And not just for the small models, but all the way to the trillion parameter models that we all love with the OpenAI models and the Anthropic models, you know, these very large models. How do you do it in a very, very power efficient way, cost efficient way? And so we created these chips that now allow us to actually drive that into what we're calling premium inference. How do you drive these chips into this market where you don't have to make a trade-off between large or fast? Today, you know, if you want fast, it's got to be a small model. Right? If you want intelligent and big, it's going to be slow. And so what we're trying to do is give everybody the ability to do premium, run these fast models for the biggest models, so you get the intelligence really, really efficiently, really, really fast.
Right. So Darrick, it's not as simple these days as just hooking up to one data center. If you're a company looking for AI power, you can be in the cloud, multiple data centers, different devices. So how do we create a system that's seamless and efficient for the businesses that need to use these systems?
Yeah, so with AI GPU clusters, which is what we specialize in, you know, the power crisis, the shortage is a really big piece of this, and it's actually driving us to be a little more diversified. It is increasingly difficult to find large amounts of power in one place, which is up until now how you build GPU clusters. You get a 100 megawatt, 200 megawatt data center, and you fill it with one big cluster. But increasingly, that's becoming very challenging, which drives companies like us to evaluate more smaller data centers as well as these big data centers, which comes with this additional challenge now for our customers, For some of them, they might be spread over multiple data centers. And for different use cases, this is acceptable. For some, it's not. For training use cases, there's a lot of reasons you want all the GPUs, all of the accelerators to be in one place. It's theoretically possible to diversify and spread over multiple data centers, but it comes with a lot of performance challenges. So not desirable from that perspective. But for inference, which is increasingly a larger percentage of the use cases, it's much more acceptable to have a diversified portfolio of sites. And it's actually, in some cases, better. It's better to do it because you can get the inference closer to where your customers are. So I think for those use cases that are more customer-facing, for inference use cases, as we continue to grow the market, I think that'll actually become a lot more common, where you have multiple data centers, one customer spread across many data centers. And what we do as a cloud provider is we make that really simple for the end user. Make it really seamless for them to have one portal, one dashboard that they can go to, manage all of their fleet across multiple data centers.
And you're finding that businesses don't mind doing that? They're not concerned about connectivity or the efficiencies?
Connectivity is certainly a challenge. That's one of the challenges that we have to solve when we offer these services. But again, it's actually beneficial for these types of use cases to be diversified, especially for customer-facing inference use cases. So yes, customers don't mind as long as you abstract it in a way that is seamless for them. Right? If it's really complicated to manage all of these diverse resources, then yeah, that would be a challenge. But it's part of the role that we play, abstracting it and making it very seamless to access these resources wherever they are with a unified control plane.
Ami, you've talked about diversification and spreading things out, about how AI is not just about being in the cloud, it's on your wrist, it's personal devices. So again, how do we make that happen? How do we bring AI to our wrists and to our smart glasses?
Yeah, thanks for having us, first of all. Well, for folks that don't know about ARM,
yes,
we've been around for over 30 years. We went public a few years ago, and our primary business was focused on licensing our design. We actually designs for others to create chips. We're probably one of the most pervasive compute platforms out there. We actually ship 350 billion, that's with a B, chips in the world. That's, to put it into perspective, that's 3 times the number of humans to have ever lived on this planet. So that's how pervasive we are. I guarantee every phone in your pocket is running an ARM chip. And we partner with everyone from NVIDIA, Google, Amazon, the largest hyperscalers, and Apple, and pretty much we're across everything. And so we have, and recently, about 45 days ago, we actually introduced our own chip, which is called the ARM AGI CPU, specifically designed to run agentic workloads, as both folks have talked about, with this push towards inference, and specifically pushing more towards agents. We introduced our own chip, really designed to be power efficient, because that's really the DNA of the company. So back to your question about scaling, and one of the things that you see over time is that everything starts in the cloud, and for it to get more pervasive and to reach kind of the scale and the magnitude we need, it moves out to the edge. You saw this with mainframes, where mainframes, many, many years ago started in the data center, and then the personal computing revolution started after that. So I think we'll start to see some of the same things happen with AI, where obviously you're going to continue to train the largest models and do some of the heavy inference/reasoning in the cloud. But in order to make the impact that we all hope to make from a humanity perspective, it needs to be able to run at the edge. And that's for cost reasons, that's for security reasons, that's for privacy reasons, for regulatory reasons. And so what we're seeing more and more is lots of interest with our partners. You take Meta glasses, for example. We have ARM-based chips in those Meta glasses, and the chips are becoming increasingly sophisticated, smart, more power efficient, more performant. So over time, you can start running the models locally, and then also have it talk to the cloud. And in those scenarios, what you need is sort of a compute platform that's able to scale from the cloud to the edge. So we got our start really in starting the smartphone revolution with the most power efficient chips. And then now data center is increasingly becoming one of our largest growth areas. And we're really focused on how do you have a common software architecture to run from the cloud to the edge, because that's actually how you get power efficiency. So we'll start to see more and more workloads as chips become more sophisticated, more power efficient, more performant. We'll start to see a lot of those workloads run at the edge. And I think that's why I'm so excited, because you'll start to see kind of the pervasiveness of what's possible with AI.
Great, interesting. Rodrigo, I mentioned the announcement by the federal minister earlier this week on data centers locally, and in doing that, he said that these data centers represented a major step forward in AI sovereignty for Canada.
Yeah.
So what is AI sovereignty? What does that mean to you?
Look, at a national level, and this is an area that we focus a lot at SambaNova, just a sovereign AI. But at a national level, what you're seeing is a hybrid environment where countries are starting to look at predominant American technologies, whether that's OpenAI or Anthropic, Gemini, building AI infrastructure and AI applications in many countries. And that's very pervasive these days. People love those models. And also understanding that, well, at some point, we need our own models that allow us to actually operate our country in our way, with our data, with sovereignty, right? And so that could be as simple as the linguistics of it. We don't want our language to be translated by, say, ChatGPT. We want our own model. And so countries like the Middle East and Japan have already started training their own models for the linguistics aspect. But it could be as much as your language, your laws, your culture. There are lots of reasons why you want the sovereign model to reflect your country or your culture or your people differently than what, say, some of these other models do. And so this heterogeneous model of having kind of the sovereign models, the sovereign infrastructure that allows your data to remain private and secure within the country, right, is incredibly important addition to the infrastructure that you are already seeing people use and build out through Microsoft and the hyperscalers and through the large frontier models that are being deployed globally.
Okay, so this is not necessarily governments building their own infrastructure.
Yeah, well, so it takes a number of different forms. Like, for example, last few months, we actually deployed sovereign clouds in Germany, in Australia, in Japan, in the UK, in France, all through partners. And so what the government wants to do is invest some amount, but the government doesn't really have the tools to deploy that capital into business that efficiently. And so they will create these funds that then entities from the country can go and secure funding to build these data centers and build this infrastructure. And so that's typically what I've seen them do, although some countries are actually doing it themselves. Mostly it's the capital, the funding is available for local entities to go secure and then build out infrastructure with the purpose of serving the country, with the people within their country.
Okay.
I think it depends. I mean, similar to what Rodrigo said, I think there's sort of we were talking backstage about how countries really look at this as capital and risk. And they have to figure out where they are on that spectrum and then figure out, like for us, we've partnered with many countries around the world, like Korea, Indonesia, Malaysia, and some of them are licensing our designs, creating a chip and systems ecosystem within that country to build their own infrastructure. And others, as Rodrigo mentioned, they just don't have that risk appetite or the capital. And so they will then purchase chips from elsewhere around the world and want to source and bring those chips into the country. Because ultimately what they're focused on is value creation to the economy. And that looks very different for different countries.
Right. Darrick, what do you see as the role of sovereign AI?
Yeah, at the end of the day, you got to think about, as AI continues to advance, how are governments themselves going to start leveraging it internally? We're already seeing this to some degree, but it's only going to get more pervasive. And so then when you have the government itself using AI for classified things or intelligence or any type of use case, there's a strong reason to ensure that they have control over where that data is going and they have control over the infrastructure, right? So this is one of the simple cases for sovereign AI, for governments to invest in building their own infrastructure. Obviously, they're going to still buy chips from the normal chip providers, but they're not going to want to send their data to OpenAI or send their data to some other AI lab that's centralized in some other country. They need to invest in their own data centers. They need to invest in their own infrastructure, their own power infrastructure to ensure that they have enough power to actually train models and run models. And they need to invest in local AI labs as well, so that the data can stay in country. That's a really big consideration, I think, for sovereign AI in general.
Right. Ami, when we were talking backstage, you made me realize that when we talk about infrastructure, it's not just buildings and chips, it's people too, and making sure you have an educated workforce that can do all the jobs that are necessary, very highly skilled folks. And your company is involved in training people as part of introducing chips into different countries?
Yeah, that's right. I mean, I think part of what people don't realize is when you start to work with these sovereign, I mean, every country now, I feel like sovereign AI or AI is a strategic priority. And so when you start to kind of look at these countries around the world and why they're building out their own AI infrastructure, a lot of it, like I mentioned, is for job creation, which is great because a lot of the infrastructure build-outs that are happening yield job creation. And so when you sort of think about that, one of the things that we do as part of our commitment to many of these countries is figuring out how we can train the local population to really manage, operationalize, and deploy these systems. Because it's not like you could just build these or set up these racks of capacity, of compute capacity, and then just walk away. You really need people within those countries to be able to operate them. And so we're spending a lot of time training the local economies to really figure out how they can manage and be successful with managing these AI infrastructure build-outs.
Right. And so we need to make sure, our politicians need to make sure, our universities and colleges need to make sure that their educational programs are aligned with these future jobs or these current jobs, that there'll be many more of them in the future from what you're saying.
Right, right.
Okay. How do we prevent a centralized monopoly from gaining control over all these data centers? Like, is that a risk?
Well, I think, from a monopoly perspective, what I firmly believe is that the open ecosystem will thrive, and so you need innovation. And you've seen that sort of time and time again with many different, technology trends over time. And so, what you hear and what you see is, 5, 6, maybe a handful, 10, sub-10 companies really focused on the CapEx build-out. But I think in order for AI to take off to the level that we need to create an open ecosystem where other companies, smaller startups, really push on the innovation envelope. And I think we're starting to see that more and more. I don't know if you guys think the same, but.
Absolutely. I think this is one thing that all of us are very aligned on. Even though we operate with different technologies, there's one monopoly that comes to mind, which is NVIDIA. Historically, less so lately, but historically they've had a complete monopoly on AI chips. And this is one of the reasons that we, when we founded TensorWave, did not partner with NVIDIA. We instead partnered with AMD because they are committed to fostering an open ecosystem, right? And I think all of us are aligned on tackling the NVIDIA monopoly in different ways and ensuring that the ecosystem is open.
Yeah, I mean, we partner very closely with NVIDIA, and we'll continue to. But I'll sort of bring back to, you look at the smartphone ecosystem, and what happened. If you just had 2 companies controlling the smartphone ecosystem, I'm not sure you'd have the many, many mobile apps that you have today in your pocket. And so I think the same thing is going to happen with AI. You're going to have a heterogeneous compute environment, which is going to include ARM and NVIDIA and the companies not by my side. But then you're also going to have a number of other ecosystem partners that are going to build on top of that compute infrastructure. And I think competition really helps drive the kind of survival of the fittest, right? So we've seen that with smartphones.
Yes, interesting. Rodrigo, you touched on it earlier. You referenced inference and what that's doing in terms of demand. How does that change the architecture of AI and the future of AI data centers and the infrastructure?
Well, I mean, several things. The first thing is people forget that inference is CUDA free, right? And so a lot of people talk about NVIDIA's moat around CUDA. Well, inference is really anchored around PyTorch models that you can download from almost any Hugging Face, any of these places, and it's open, right? And so I think that's kind of created this environment that allows all these different architectures to be available for people that want to run their models, because it doesn't matter what it was trained on, because inferencing is now general purpose and open. And so that's one. I think the second thing that we're seeing now with a lot of players is starting to think about heterogeneous data centers. And so you see the hyperscalers moving into it, whether it's their own chips, with NVIDIA chips, with AMD chips, with SambaNova or other startup chips, right? Because what you're seeing is different models, different workloads have different characteristics that allow different type of infrastructure to come in and operate more efficiently. And efficiently, I mean by power, by space, by cost, right? And so if you have these types of models that you're inferencing, you could run here. If you have these types of models, you can run over there. And for example, like we take these models for inferencing. We really focus on open source models, some of the largest models. And we come in and we say, we don't run everything that NVIDIA runs. That's not our intention. But if you're running inference, of which in your cluster is the large majority of what you're running, a single rack of SambaNova will outperform an NVIDIA rack by 5 to 10x. And so it makes no sense for you to run those workloads there, because you can route this and frees up NVIDIA GPUs for training other things that we can't do. And so I think more and more you're starting to see data centers start to think about this heterogeneous model. How do I mix and match technologies from all these different suppliers? Because we are focusing on certain things. And if we do those better than incumbent, it will free up the legacy infrastructure to do the things that they do better, and allows you to really mix and match and actually create the best blend at a data center level instead of at a chip or a rack level.
Mm. So Darrick, as these data centers evolve, how does that shift the balance of power between CPU and GPU?
Yeah, that's a great question, especially with agentic workflows that are starting to become a lot more popular. We're actually seeing a rise in CPU demand as well. That is in line with our strategy already, because we are so partnered with AMD. AMD is, at the moment, the world's most popular CPU provider. And that was starting to be true even before they released their GPU offering a few years ago. And so now with AMD, we are well positioned to support arbitrary ratios of CPUs and GPUs, but we are seeing an uptick in CPU demand for some of these agentic workflows as well. So I expect that will increase, that trend will keep going, and we'll see a little bit more CPU demand as we go on. But I don't think that we'll ever get to the point where it's replacing the need for GPUs. It's always going to be a balance.
Okay, is that what you're seeing as well, Ami?
Yeah. I mean, I think I'll argue with Darrick here about AMD being the most popular CPU, because I argue that ARM is, but we'll take that backstage. I think what we've seen is obviously this trend towards agents, and specifically that was driven a lot by the open cloud moment that happened a couple months ago. And I think what we've seen is that when you look at agents being deployed on compute, the best compute that those are deployed on is the CPU. And so we saw this renaissance moment for CPUs. And for us, one of the things we really focus on is back to power efficiency. If you can have the most power efficient compute to run those agents, the more agents you can run in that gigawatt of capacity. And so we really focus a lot of our efforts on making sure we have the most power efficient CPU and we can run as many agents as possible. And I think those ratios of what used to be 10 to 1, meaning 10 GPUs to 1 CPU, or 8 GPUs to 1 CPU, whatever your math was, it's definitely trending more and more towards more CPUs to GPUs. To Darrick's point, that doesn't mean GPUs are going away. You're going to still need many, many accelerators to train the large models, for tokens to run. What CPUs are great at is a lot of the orchestration that manages all of those agents, and agents can literally run on the CPUs themselves. So I think you'll need both. Those ratios will just change in favor of more CPUs to GPUs over time.
Mm. And well, that's Rodrigo. That's a lot of what you're talking about as well, right?
Yeah, exactly. I think we've been talking about, I think cost is important.
Yes.
Power is important. Scale is important. Access, inference, all those things are important. What we're seeing now with the agentic flow, it's one of the very popular use cases is code generation, right? You look, software engineers using code generation, and companies like Anthropic with Claude, they've done just such an amazing job creating a model that produces code that's better than what many of the top software engineers could create in over weeks, if not months. They can generate it in minutes, right? And so I think that they've done such a good job. And yet, what you're seeing is the cost structure for companies to continue to do that is growing very, very quickly because the compute is expensive, right? The time to compile, as smart as it is, the time to compile that code can be as much as 20, 30, 40 hours, right? Where you really want to see that become a lot more real time. And so I still think that you're going to, even with kind of as much AI as we're all talking about, as much AI as we're all consuming, we're just in the beginning. Because with SambaNova, we're seeing this code gen use case where we're able to take open source models, run it significantly faster, and then suddenly that 24-hour, 25-hour compile time drops down to 45 minutes. And so then you get same quality code, but now the software engineer that's using is now iterating at a pace instead of saying, oh, I got to come back tomorrow night, right? And so I think those types of things are still yet to come, and we're starting to see so many people come in and take those use cases and start deploying them, because in the end, I don't think, we all like to talk chips, we want to talk models. In the end, for them, is productivity. Right? What they care about is how much am I getting done any given day? I don't want to wait, I don't want to spend a lot of money, and I don't want to waste time, right? And so if we're able to give them very, very fast results to increase their productivity and the cost is low, right? You're going to see the scale in a way that you've never seen technology go this fast. It's already faster than almost any technology adoption we've seen, right? But I think you're going to see the next wave go even faster.
Well, let's talk about the next wave. We only barely have a minute left, so I wish I had a little more time to get you folks on the cutting edge to talk about what you see in the next 5 to 10 years. What?
Yeah, absolutely. Right now, it's massive scale out. And one of the biggest bottlenecks to supporting that scale out, back to the beginning here, is power infrastructure, right? So what we see happening in the next 5 to 10 years is a massive uplift, countries across the globe in their core power infrastructure. And I think this will actually be one of the positive outcomes from the AI boom, is that it will really push countries to adopt newer, cleaner, larger power infrastructure that will support them for decades to come. So that will be very beneficial, but that build out, it takes time, right? And I think over the next 5 to 10 years, we'll start to see a lot of new power generation come online, a lot of power infrastructure be upgraded at a global scale.
I mean, I think that you'll probably see three things. One is power, which we talked about, and I think you'll see alternative sources of power. I think you'll see capital. It's tremendously expensive for all this compute and all this infrastructure build out, and I think you'll see lots of unique partnerships, and we're already starting to see those in order to kind of build what you need possible. And the third is supply chain resilience. And when you think about what we're doing, where they're localized, I think you'll start to see supply chain resilience built across the world. But I think if you sort of look at these three things, it's all about scaling challenges. It's not something that we haven't solved before. And so I'm tremendously optimistic about what we'll be able to see in the future. And I think we'll be able to see what AI is capable of in terms of changing humanity.
Last word to Rodrigo.
I think AI is going to be real time. Speed's going to matter. It's going to be constant. And that's going to drive the edge. It is going to drive enterprises putting things in their apps at all times and running constantly. Today, if you actually look at it, most AI is prompted by us. I think over time, AI is going to be just a 24/7 always running type of model and behind the scenes. And we only snapshot it when we see it, but it's constantly running. And so I think that for that, efficiency matters, cost matters, but most importantly, speed matters. And I think you're gonna need to solve that so that people can see what they want to see in real time.
Great. Well, we're out of time. Darrick, Ami, Rodrigo, thank you for joining us today. Please join me in thanking them.